If money doesn't grow on trees, why do banks have branches? Why do we say we are head over heels in love when that is just how we normally stand? If a deaf person goes to court, is it still called a hearing? And seriously, why do Americans build houses out of wood that can easily burn or blow away in a hurricane, while much of the rest of the world relies on heavy masonry and reinforced concrete? Welcome to Midnight Questions. Today we are answering, why do some countries build houses out of wood while others use concrete? Before we dive in, if you're new to the channel, make sure to subscribe so you don't miss our future late-night explorations. Watch a Hollywood action movie, and you will eventually see a fight scene where someone gets thrown backward, easily smashing through a layer of drywall and a few wooden studs. But walk down a street in the Middle East, Europe, or North Africa, and the architecture tells a different story. These homes are built with the weight and permanence of steel and reinforced materials. Why does a global superpower construct its homes using this lightweight wooden skeleton, while other regions prioritize the density of stone and concrete? When early European settlers arrived in North America, they faced an immediate logistical crisis. They needed to construct millions of homes for a rapidly expanding population. Bypassing the slow process of baking clay bricks, they turned to the massive forests surrounding them. Raw timber was a cheap, immediate solution that required significantly less infrastructure to process. Wood possesses a specific physical property that made it essential for northern survival. It is an effective thermal insulator. This diagram compares the heat transfer rates of common structural materials. On the left, thermal energy rapidly escapes through a standard structural steel beam. On the right, that heat remains trapped by the wood. In a direct comparison, wood insulates 50 times better than steel. In the extreme winter cold of the US and Canada, these wooden frames act as a barrier, keeping internal heat from leaking out and saving massive amounts of energy. The American reliance on timber was an efficient adaptation to a specific environmental challenge, surviving the freezing temperatures of a new continent. In East Asia, countries like Japan and China also utilized their vast timber supplies, but they developed a different engineering philosophy based on local geography. In this region, the primary environmental threat is not just the cold, but the frequent and violent activity of earthquakes. Rigid construction is a liability in a seismic zone. Stiff masonry and concrete cannot absorb the energy of a tremor, causing the material to shatter and collapse. To solve this, ancient engineers developed complex, interlocking wooden joints that required no metal nails. These connections allow the entire frame to flex and sway during a quake. By sliding with the vibrations rather than resisting them, the house can ride out the seismic waves without structural failure. In a tectonic environment, structural flexibility is often a more effective survival technology than rigid permanence. The Middle East presents the opposite challenge, a landscape with almost no timber, but an endless supply of sand and limestone. With earth as the only abundant resource, builders mastered the use of thick earth walls and masonry to regulate temperature. This is the principle of thermal mass, using dense materials to absorb heat during the day and release it at night. Under the scorching desert sun, the thick stone acts as a buffer, slowly soaking up solar radiation while the interior of the home stays cool. As the desert cools after dark, that trapped heat radiates into the house, keeping occupants warm during the freezing night. These homes function as a balanced thermal battery, tuned to the extreme cycles of the desert. Today, the traditional logic of geography is being challenged by the growth of global megacities like New York, Cairo, and Tokyo. As populations grow, the land area required for single-family homes is disappearing, forcing cities to build upward. This shift reveals the logistical limits of traditional materials. You cannot stack mud bricks or wooden logs into a 30-story high-rise. Supporting that vertical density requires the specialized load-bearing strength of steel and reinforced concrete. While our past was defined by materials pulled from the local landscape, our urban future is increasingly built on a global standard of concrete and steel. What is the weirdest question that has ever popped into your head in the middle of the night? Let us know in the comments below so we can explore it in a future video. If you enjoyed this, don't forget to like, share, subscribe, and hit the bell icon. See you next time.